We're now going to start the section called Coordinate Geometry, sometimes known as Analytical Geometry. And we're just going to go through the formulas that you learned last year. So first of all, there's the distance formula. And the distance formula is AB is equal to the square root of x2 minus x1 in a bracket squared plus y2 minus y1 in a bracket squared. And what you need to be careful here is those two minuses in the brackets and a plus between. And the way I like to remember it is that I need two minuses to make one plus. So there's negatives in the bracket and a plus between them. Then you get the midpoint of the line segment, and that is just adding the two x values and dividing by 2 and adding the two y values and dividing by 2. And this is the one formula we don't need to see. We're quite happy with the answer only. Moving on to gradient. Gradient we've been doing for a while now. It's y2 minus y1 over x2 minus x1. And the gradient tells us a few other things as well. First of all, if our lines are parallel, they will have equal gradients. And if our lines are perpendicular, the one gradient multiplied by the other gradient will give us minus 1. Then we move on to the equation of a straight line that you need to remember. Y equals mx plus c. And finally, the last thing we learned in coordinate geometry is about inclination, or the slope of the line. And because the slope of the line changes with gradient, it is y over x. And the trig function that works with y over x is tan. So tan theta is equal to your gradient. Now let's try and take these formulas and work out a specific example. In example 1, in the sketch below you have triangle ABC, and the first thing we need to try and determine is the distance of AB. So I first write down my formula and remember those two negatives in the bracket and the plus between. Then I'm going to look at B and A. Now I've chosen to label B as x1 and y1 and A as x2 and y2, but you can swap them around, it's not a problem. So if I substitute them, x2 will be minus 1 minus x1, which will be 3. So minus 1 minus 3 in the first bracket, and then y2 minus y1, so 3 minus 0 in the second bracket. Now remember, first simplify the values inside the bracket. So minus 1 minus 3 is minus 4, which I still need to square and keep it in a bracket. And 3 minus 0 is 3, which I still need to square. Minus 4, if I square it, I get 16, positive 16. Remember, anything squared will be positive. And 3 squared is 9. 16 plus 9 is 25, and the square root of 25 is 5. Now, it's not necessary for you to show all of those steps. You do need to show us the formula and then the substitution, so steps 1 and 2. You can then type it into your calculator to get the final answer. We're now going to look at the midpoint of AC, which is halfway along the line AC. To determine the x coordinate of the midpoint, we're going to add the two x values and divide by 2. And to get the y coordinate, we're going to add the two y values and divide by 2. So the two x values, I've got minus 1 plus 6 divided by 2 gives me 5 over 2. And the y values, I've got 3 and I've got 6. So 3 plus 6 divided by 2 gives me 9 over 2. So that midpoint has coordinates 5 over 2 and 9 over 2. And don't be tempted to go to decimals. Common fractions are much easier to work with. Next question is to determine the gradient of AB. So I've got coordinate A and coordinate B. Now the formula is y2 minus y1 over x2 minus x1. You can choose whichever coordinate you want to use first, but make sure you use it first on the top and on the bottom. So I've decided to use A first. So the y values will be 3 minus 0, and the x values, I have to use the x value in A first, so minus 1 minus 3. And I end up with a gradient of minus 3 over 4. We're then going on to determine the equation of that line. Now the equation of a straight line is y equals mx plus c. we've calculated our gradient, so y is equal to minus 3 over 4x plus c. And we now need to substitute in either a or b, because I want the equation of ab. And I'm going to choose b. And the reason is it's got a 0, so I try and work with zeros as far as possible because they're easy to work with. So if I use b, the y value will be 0 and the x value will be 3. We need to multiply minus 3 over 4 by 3, and maybe you want to do it on your calculator. Please don't make the mistake of going 3 times 3 and 4 times 3. There's only one 3 there, so minus 3 over 4 times 3 gives me minus 9 over 4 plus c. And if I get c on its own, I end up with a c value of 9 over 4. So the equation of AB is minus 3 over 4x plus 9 over 4. We need to determine if BC is perpendicular to AB. If BC is perpendicular to AB. Now, how can I do that using analytical methods? Well, remember, if lines are perpendicular, one gradient multiplied by the other gradient is minus 1. And always make sure, have you calculated one or both gradients in previous questions? Well, we have calculated the gradient of AB in the previous question. So the gradient of AB is minus 3 over 4. I haven't calculated the gradient of BC yet. So BC, we're going to go y2 minus y1 over x2 minus x1. And I've chosen to use C first. So 6 minus 0 over 6 minus 3. And I end up with 6 over 3, which can simplify to 2. So now if I want to prove if these lines are perpendicular or not, I'm going to multiply those two values together. So minus 3 over 4 times 2, I end up with minus 3 over 2. But I should end up with minus 1, and I don't. So if I don't end up with minus 1, it means that CB is not perpendicular to AB. We need to determine the inclination of BC. Now remember, the inclination is that angle between the positive x-axis and the line. All right, and that inclination will change with the gradient changing. So the formula is tan theta is equal to m. Now, just double check, have you worked out the gradient of BC already? And we did in the previous question. So use it straight away. So tan theta is equal to 2. Now we want to find the angle. So on our calculators, we will go shift tan 2. And we end up with 63,4 degrees, correct to 1 decimal place. Next one, we want to determine the equation of the height of triangle ABC from C. Now what you need to remember is the height is always perpendicular to the side that it touches. In other words, the height is going to be perpendicular to AB, which means I need the gradient of AB first, and then I can carry on. Now, if the gradients are perpendicular, m1 times m2 will be minus 1. So the gradient of AB, we did work out in a previous question, was minus 3 over 4. So the perpendicular height, remember, you can either do a little calculation by substituting it in, and then if you'll take it over, you'll tip in times, or what is much easier to do is just to change the sign of the fraction and swap the fraction around. So you had minus 3 over 4, so if you switch it around, you'll get positive 4 over 3. So you don't have to show us the little calculation, you can just write down that the perpendicular gradient is 4 over 3. Okay, so now, if we have a look here, we want y is equal to 4 over 3x plus c, and I still need to calculate c. If I look at my sketch, the only point that that line is touching is c, so that is the coordinate I have to use. So it's always a bit confusing, which coordinate do I have to use? The one that the line is touching. So I'm going to substitute in 6 and 6. Now again, remember, don't multiply 6 to the top and the bottom of the fraction, only to the top. So 6 times 4 is 24, divided by 3 gives me 8. So 6 minus 8 is minus 2. So my C value is minus 2, and I substitute it back with my gradient to get the equation y is equal to 4 over 3x minus 2. In the next question, we need to determine the coordinates of D if ABCD is a parallelogram. Now you may be asking, where is D? Well, we've got to figure out where it is. And the order of the letters that they ask the question in is very, very important. So they've asked me for A, B, C, D. So moving in a circle, I've got to move in that order. So I'm going to start at A, move to B, move to C, and then I have to get to D. So D is going to be up top here somewhere. All right. So there's my parallelogram. And now you just need to do it by inspection. So we will give you 2 marks for the answer only. And you are going to use parallel lines to answer this question. So if I look at AB, the other line I will use is CD. So I have to ask myself, how do I get from 3 to minus 1? Well, I'm going to subtract 4. So I have to do that on the other side as well. So 6 minus 4 is 2. Then you ask yourself, how do you get from 0 to 3? Well, I add 3, which means I have to do the same process on the other side. So 6 plus 3 is 9. So just go through that again. Ask yourself, how do you get from 3 to minus 1? You'll subtract 4. So you do the same on the other side. So 6 minus 4 gives you 2. And you do the same with the y values. We're going to look at another example so I can show you that the letters are very, very important, the order of the letters. So now we've got A, B, H, C, which means I've got to move from A to B, but then I have to reach H before I get to C. So H is going to be somewhere on this side instead. So the order is very important. You've got to go A, B, H, C. You have to work in a circle. All right, so now this time my parallelogram is finished off on this side, on the right-hand side. So ask yourself the question, how do I get from minus 1 to 3? Well, in this case, I'm going to add 4. So I will do that on the other side as well. So how do I get from C to H? I must also add 4. So 6 plus 4 is 10. Then if we look at the y values, how do I get from 3 to 0? I have to subtract 3. So I do exactly the same on the other side. So 6 minus 3 gives me 3. So the coordinates of H will be 10 and 3. Thanks for watching Max Maths. If you liked what you saw, please like, share and subscribe.